Prove the identity cos A over cos A minus sine A plus sine A over cos A plus sine A equals 1 plus tan 2A. So remember, when we are proving an identity, the way I would suggest approaching it is take the left-hand side and try to turn it into the right-hand side. So firstly, if you just look at the left-hand side, you've got a sum of two fractions. On the right-hand side, you can't see any fractions for starters, but I would suggest the first step is to combine these fractions, and you've got some good clues in there. You can see, if you consider the denominators, you've got cos A minus sine A and cos A plus sine A. So if I multiply those together, we've got a difference of two squares going on there, so it's already going to look quite nice. And then if we can make squares, so once we multiply things, as in once we multiply the cos A by the cos A plus sine A and the sine A by the cos A minus sine A, we're going to have a lot of squares going on. And if you just look at these identities at the top, once you've got squares, and there's the Pythagorean identity as well, sine squared theta plus cos squared theta equals 1. Once you're making a lot of squares, you can make some nice simplifications, because we're going to need a lot of simplification to get to the target of 1 plus tan 2A. So the first step, we are going to add the fractions. So this is going to be cos A plus sine A plus sine A cos A minus sine A all over cos A minus sine A cos A plus sine A. Okay, so remember, it is a proof. You don't have to write everything, but you should explicitly show the examiner that you understand every step. So don't leave him or her guessing, did they really understand what they were doing or not? You don't want that situation. So we are going to show a few lines here. Cos squared A plus sine A cos A plus another sine A cos A minus sine squared A all over, well, on the bottom, as I was saying earlier, it's a difference of two squares, so it's A minus B times A plus B, which is A squared minus B squared. So A in this case being cos A and B being sine A. So it's cos squared A minus sine squared A. Okay. So we can see, whilst we're not going to get to use the Pythagorean identity, we are going to get to use the double angle identity. So you can see we've got this cos squared theta, or A in our case. That is looking like it's going to appear on the top and the bottom, so we're going to be able to substitute there. And also, we've got you've got two lots of sine A cos A. So if once we do the grouping that we're going to do in a minute, we're going to be able to use two double angle substitutions. So, and as I was saying, to explicitly show the examiner that you know what you're doing, I am going to take the extra line. I'm just going to put things together. So I'm going to put the cos squared A and the minus sine squared A together. So cos squared A minus sine squared A plus, and we have we've got a sine A cos A and another sine A cos A, so that's 2 sine A cos A. All over. So you could show now that you recognize that this is cos 2A, Or we could, because we're going to have to do it on the top anyway, I might just leave it for now. Okay, so now we are going to substitute. So if we go back up to the top where the identities are, you would be looking in a formula book. You know that sine 2a is 2 sine a cos a, so we put that in there, and cos 2a, one of the identities is cos squared a minus sine squared a. So now this becomes cos 2a minus sine 2a over another cos 2a. And if we just remember what we are aiming at, we're looking to show that this is 1 plus tan 2a. So what we are looking to do, if we split this up, as in if we say, well, this is cos 2a over cos 2a minus sine 2a over cos 2a. Now we've got our 1 because cos 2a over cos 2a is 1, and we have our minus tan 2a because sine 2a over cos 2a is tan 2a. Remember, that's the second most common and second most important trig identity. So now we have equals 1 minus tan 2a as required.